What I want to do in this video is prove that the circumcenter of a right triangle is actually the midpoint of the hypotenuse. And to do that, I'm going to first take a look at the perpendicular bisector of one of the legs of this right triangle. So let me construct the perpendicular bisector of leg BC right over here. So it's going to look something like this. It's going to look something like this. It intersects at a right angle, it's perpendicular, and it bisects it. So B, the distance from B to this point, which we'll call M, maybe M for midpoint, is the same as the distance from M to C. So those two distances are going to be equal. And let's call the point where this perpendicular bisector intersects the hypotenuse, let's call this O. And we're going to prove that O is the circumcenter of this right triangle. Now, the first thing that you might realize, and this is what we've seen in many problems, the triangle OBM looks similar to triangle ABC, and it's actually not too hard to prove. They both already have a 90-degree angle, so if we show that they both have another angle, another set of corresponding angles that are congruent to each other, then we know that they're similar by AA similarity. And they both clearly share this angle right over here. OBC is part of the smaller triangle, and ABC, which is really the same angle, is part of the larger triangle. And they also obviously share a 90-degree angle. So by AA triangle similarity, we have triangle OBM is similar to triangle ABC, is similar to triangle ABC. And what's useful about this is we know that similar triangles, the ratios between corresponding sides are a constant. So for example, we know that the ratio between side BM, which is on the smaller triangle, we know that the ratio between BM, let me do this in a different color just for the sake of it. We know that the ratio between BM and BC, the ratio of this side on the smaller triangle to the corresponding side on the larger triangle is going to be the same as the ratio of the hypotenuse on the smaller triangle, BO, to the hypotenuse of the larger triangle, because they are similar. Well, we know what the ratio of BM to BC is. BM is half of BC. So this ratio over here, the ratio of BM to BC, is going to be equal to 1/2. This is M is the midpoint of these things. So this is exactly the same distance as this. So this is 1/2 of the entire BC. So if 1/2 is equal to BM over BC is equal to BO over BA, we then know, if we just kind of ignored this middle part right over here, that 1/2 is equal to BO over BA over BA. And if you cross multiply, you see that, well, there's multiple ways to think about it, but you could just cross multiply and you'd say BA is equal to 2BO. Or if you divide both sides by 2, and they're really equivalent statements, 1/2 BA is equal to BO. So BO is 1/2 of BA. So this is 1/2 BA. And so this other length, AO right over here, this is going to be BA minus 1/2 BA. So this is also going to be 1/2 BA. And so this segment right over here, AO is going to be congruent to OB. So what we've just shown, first of all, is that this perpendicular bisector right over here, the perpendicular bisector of segment BC, it intersects the hypotenuse of our right triangle at the midpoint. So we've already established, one thing that we've already established is O is the midpoint, of the hypotenuse, AB. Well, that by itself is interesting. But we also know that if a point sits on a perpendicular bisector of a segment, it's equidistant from the endpoints of the segment. We showed that in a previous video. So we also know that OB, it's equidistant from the endpoints of this segment right over here, that OB is equal to OC. But we know from this first statement right over here that OB is also equal to OA. OB is also equal to OA. And so if OB is equal to OC, OB is equal to OA, that means OC must be equal to OA. OC must be equal to OA. Or another way to think about it is that this point O is equidistant from all of the points on our all of the vertices, I should say. This point O is equidistant from all of the vertices of our triangle. So this distance this distance, which is really going to become our circumradius, is the same as this distance right over here, which is the same as this distance right over there. So that we know that O is equidistant to all vertices, which is another way of saying that O is the circumcenter. O is the circumcenter. So we've just proven that if you have the circumcenter of a right triangle, it is the midpoint of the hypotenuse of the right triangle, or the other way around, that the hypotenuse of the right triangle is the circumcenter, because you only have one circumcenter of any triangle.